Okay, good evening everyone. Let's get started. So today we're going to talk about something about testing. Okay. Yeah. Testing. Alright. Before we talk about testing, let's have a little bit of overview of what we learned last time. So last time we're in Unit 5. We go through some lecture of regarding the UML, the diagrams. Those diagrams, that's maybe helpful tools which can help us with our design of the whole system. Also, we learned a little bit about this requirement, the use case flow. Okay, so the use case flow is something we have a main flow, right? And what else do we have? We have three kinds of flow: a main flow, can remember that? Optional, yeah. Alternative flow. We have main flow, alternative flow, and those exceptional flows, right? Yeah. So the main flow is before you reach any branch in your code. Not exactly the code. So before you reach any branch into your system logic, like when I log into the system, I open the web page, I find the login page, I log into the system, I select my rule. Before this, everyone is on the same page, on the same flow. So that's the main flow. Then we have alternative. We go to the student flow, we go to the professor flow, we go to the administrative flow, and then that's the different options. So we call it alternative flow. You have different options. And also when you are executing each step, sometimes something that's not a main flow, either alternative flow. It's something kind of like the exception, like okay, the password is invalid, right? Like your input is invalid, something like this. It goes to those kind of exceptional flow, right? Yeah. So let me see. That's an example. Yeah. I'm sorry. So the main flow, subflow. Sorry, it should be the main flow, subflow, and alternative flow. Alternative flow is the exceptional flow, but subflows are really the branches, whether you are a student, a faculty, or administrative in the course selection system. And main flow is like everything. We have those flow in common, right? The main flow. Yes. So that's the use case. It's help us to gather requirement, because with this kind of description, first you can clearly state your system logic to all the stakeholders. You present that very clearly, try to avoid ambiguity. Also, well, from this description, we know that what the system needs to do. We know what is the user's ability. We know what is the system's ability, the boundary of the system. We know what should be taken care of in the system, and what is the input from the users. Okay, so the responsibility of the system and the users distinguished. All right, so that's a design. We design with UML, and we design with UML. UML is a whole bunch of tools, a set of tools. Like we have a sequence diagram, we have this class diagram. All of those, they're helping us to actually modeling the system, okay? Visualizing the system. Okay, so today Let's first talk a little bit about the testing. Okay. Well, after we plan for we learn the system planning. We learn the system. We design with this UML. We learn the requirements a little bit. Now, one step here is also very important. We haven't touched it. Is the software testing. Okay. So before talk about it, I know somebody is taking software testing courses as well, right? It's a graduate level testing course, right? Graduate level. Okay. So to describe what is software testing? Why do we need the software testing?
For example, if the developer creates a software, then user wants to use that software, but in a bad way, in a different ways, which is not created in a software. It makes error and problems. So there is some groups, they name it testing groups. They have to create different kinds of possible errors and error or faults, which can create failure for software. They have to think all the options, all the problems maybe can create a failure for the software, and provide it for the software to give opportunity to don't fail.
Oh, well, actually, yes. That's described. Well, some situations that which can lead to the software crash, especially those cases, test cases that's out of the expected value, right? Out of that boundary. Okay. So have you ever? Well, I believe most of you did. So develop system, but you do a testing more or less, right? After you're writing a code, right? You try to say, okay, let's go. I'm just trying to run it and give some value to see if it's work or not, right? So what kind of value do you usually give for your code? Like just a general value, right? Like for example, if I want to test if I have a system that I have an input box that takes the password. Maybe the password needs to be longer than 6 digits but shorter than 10 digits. Okay, something like that. So when you're trying to verify that, so what kind of value do you usually give? Usually you give between 6 and 10, right? So like normal range of that. But sometimes, because when you're implementing your system, you have that functionality in your mind. Sometimes the value within that range, most of the time it creates less problem than the value that is out of that boundary. Okay, and that's what you just mentioned. That's why all those values out of boundaries, well, it's usually that's most of cases which result in the this software bugs there. Okay, so here we're talking about testing not only by the testing technique, not the testing technique, but we are talking about testing in maybe a level above, in a system, from a system level. Okay, when we're talking about testing, we're talking about there's certain functionalities when we're testing that. Okay, we give value, but when we're designing a system, sometimes it's more than just functionalities. Okay, sometimes it's more than just functionalities. Well, first let's talk about this unit testing and integration testing. From this name, you should be able to understand what are those, right? Unit testing, integrated testing, something that is dealing with individual, and integrated testing is something that dealing with everything together. But what is the purpose of unit testing and individual testing? So unit testing is like the individual components should be individually tested. Okay, because when we are trying to build a system, it's usually composed from different modules. Like let's still take the course registration system for example. Okay, it has a module for maybe database. It has a module for database handling all those data and store the data, retrieve the data, right? It has a module to maybe for security module to like doing the verification, make sure you're logging correctly, and it has a module to ensure that every policy, to enforce the policy that like you have to select, maybe if you're a full-time student you have to select more than 9 credits, or if you're a student selecting those courses, at least the system will ensure that the courses you selected do not have the time overlap, right? That's maybe a module of the policy trying to ensure that's not happening. Or something like prerequisite testing, not testing, prerequisite. We try to check if a student wants to register for this course, has he meet all the requirements? Well, that's maybe another algorithm in a separate module, maybe called policy enforcement, something like that. So we have in a system we have a lot of modules. A system is composed from different modules, but when you are developing every different modules, usually first all those modules they are at least tested individually. So that's called unit testing. Right? It's easy to understand. And in each module, when we do unit testing, we have a lot of different techniques, like what we just talked. Maybe a boundary value, boundary conditions. Okay. Also, we can use white box testing or black box testing, which we'll talk later. For individual unit, we test that. We test basically most of the time it's a functionality. Okay, and second is integration testing. Okay, but why do we need integration testing? Since if we already done the unit testing, why can't we just put everything together? Why do we need integration testing? Try to use your common sense to think about this question. Do we really need integration testing? Why?
We need to verify if this unit, this function, this method cannot or work together.
Yeah, we need to verify if they work together, yes. But we have a module A which works perfectly, module B which works perfectly. But what makes you think that these two, when we integrate them together, they won't work properly? What makes you think so? What makes you think there's a possibility that two perfect modules won't work properly together? So what may leads to the error there? If we have a module A and module B, okay, they are both perfect module, let's assume. Okay, but when they work together, what can possibly lead to the error there? Yeah, yes, there will be error. There may be error, yes, but where is the error? Is it from module A or module B?
No. It's like there may be.
Okay, let's think about this software. Let's think about a couple, husband and wife. Maybe they are all perfect person. in their maybe community, family, they're excellent person, okay. But sometimes when two excellent person, perfect person, when they marry together, there will be something wrong there, which leads to maybe bad relationship and maybe a bad collaboration in the family. So what caused that? Well, when that happens, we say these two person they do not match, right? They do not match. So here in the software, these two modules, they may also have the problem. They may work perfectly individually, but when they work together, they may not match each other. So the problem is the interface, right? The interface between these two modules. Those two modules, they need to talk to each other. Okay. So if I am a module that I process the float perfectly, and there's a module which takes the float. So I'm a module processing the input of the float, and there's another module here process the maybe the calculation, maybe the sum, the minus, the plus, minus, those things of integer. Okay, I work perfectly dealing with float. This module work perfectly dealing with integer. But when I take a float and pass a float to this module, it won't work, right? Because the interface is not well defined, right? So the interface should be if an integer, then I need to input the integer there, right? Well, if I'm outputting float and this module is taking integer, is there any possibility I can still work with this module? Well, think about when you travel to Europe. When you take a computer, maybe this kind of plug, it doesn't fit. So what do?
Use an adapter.
Yeah, adapter, a converter, adapter, right? So yes. So here, if two modules it doesn't work very well, you're in the interface, there's some problem, and sometimes we use adapter to connect to different modules. Maybe this adapter, or we call it interface or adapter, there may be something wrong there, right? So this integration testing, it's more about we are trying to testing this interface between these modules instead of testing the each individual unit. Okay, so we assume that okay, every individual unit is okay working well, but we want also to test the interface which makes them working together. That interface or that adapter, converter, adapter, that thing works well. So that's the purpose of integration testing. Got it? Cool. Okay. And that's another problem here. So when we're trying to do the integration testing, do we always assume that all the unit testing? No, not this one. So when we are doing the integration testing, it seems we need to have at least all the unit testing done already, right? Because if we do not have those components, how can we test the interface, right? But there are some situations we can do the integration testing without all the individual components that's being done. So that's two different things. One is called top down, one is called bottom up. Okay. So bottom up is easy to understand. Bottom up, okay, so in which the entire system must be completed, right? Before we're doing the testing. Yeah. Before we're doing the integration. Okay. So that's easy to understand. We first develop every individual components. We test the individual component, and then we integrate them together to test the interface. Okay, that seems straightforward. Yes. But what is top down? Top down here. This description here. Top down, depth first is better. Allow one to complete features of a system one at a time. So that's well, a little bit confusing. How can we do this top down? Like we can do integrate. Now, like I can tell you that we can test the interface even before we have all the individual components. But how do we do that? So usually we use something called stubs. So what is the stubs? Yeah. Yes, yeah, something like that. Yes. So sometimes when we have a stub, okay. So when we're trying to call each unit, when we're trying to do the integration testing, really we're trying to call the module, if different individual module, and when we call the module returns some value to you, right? And then we're trying to see the value. This is if the value from module A works with the value from module B, if they work together, if they're good or not. Okay, but now actually this kind of calling can be substituted or can be faked, right? Actually, if I say, okay, this module is a face recognition algorithm that returns the maybe the coordinate of the person's eyes in the picture. Okay, this whole algorithm may be pretty complicated. You've got to go through and find the eyes of the face, right? But before we implement that, we can just write a line of code. When we call this module, it returns coordinate. We can just fake a coordinate and pass it back. So that when we actually implement this module, we have this fake code section there to make the whole system running. Okay, so what all the system trying to get in the integration testing is a code, is a return value from every individual unit. But here, when we're trying to integrate, we have a fake function there, just fake the output, and then what we want to do is use that output to testing that interface. Remember, the integration testing is about interface. It's not about the functionality within each unit. So it's fine to fake those kind of call. We call it maybe stub. So code written to substitute for a calling module, and stubs represent the module that are called by the code being tested. Okay, any problem with this part? Yeah. So that's bottom up is easier to understand, but top down is really a concept that tells you that integration testing is a test of the interface instead of the functionality within each unit. Okay. And we have another thing called regression testing. It's done on previously tested code after change being made. So what does that mean? So that means, well, simply speaking, you find the code, you fix the code, and you run those test cases again to see if the bug fixed. So that's something like regression testing. Yeah, repeating the tests have been done before to be sure have not changed after removing a specific error. Okay, because sometimes when you, well, you all know, you are all aware of this thing, like when you fix a bug, it may introduce more new bugs in the system, right? So that's make this regression testing even more important. And this fix may cause new errors. It doesn't mean the fix didn't work. What it means is that there are more faults to be fixed. Yeah, eliminating an error causes the introduction of a new one about half the time. So it's highly possible when you remove a bug, you introduce new bugs. So that's normal. Don't be afraid. Just keep on testing. Fix more bugs. Yeah. And system testing. So it's the final level of a test. So actual tests on the target machine. It's the system is system testing is maybe a level up again. So it's not only about the functionalities. It's not only about the interfaces anymore. It's also about the environment where you deploy the system, right? So you deploy system on the phone or on a very old, maybe a very old server, or it's maybe on AWS, right? Who knows? But usually this kind of running environment is predefined when you are before you developing the software. So the system testing, usually you put it in the target machine. To do so, no, not to do so. So if you do so, what's being enabled is first you run the testing. Yes, the functionality is test a little bit, but it's not the main purpose. Here the test is performed on the actual target machine, so it allows us to check some unfunctional requirements as well. What is unfunctional requirements? It could be the security, the performance, like when you're trying to search Google, where it returns the result pretty quick, like within half a maybe 0.2 seconds, something like that, right? But if you okay, I have a perfect algorithm which works way more better than Google. That's possible, but it returns the result after an hour. Does it make sense? Right? So, usually this non-functional requirements is also a very important part of the system requirements. So, this kind of system testing is also checked for the performance requirements, efficiency, performance, and security, which is also called non-functional requirements. Okay, and functional requirements, you all know what those, right? That's the system's maybe functionality, behavior, functionalities, not the efficiency, performance, security. Okay, and acceptance testing. Acceptance testing is assure the customer that the system actually does what it is supposed to do. The test process is specified by the user. Remember, user is involved here. So for performance must be demonstrated. It is done in the client's domain to the client's satisfaction. And this, when you testing that, you have the criteria to evaluate if the testing case is passed or not. So its criteria is created, set in the contract with the client. And the goal is not error detection, but determining if the system is acceptable to the client. Okay. Yeah. So, we all heard of this. Sometimes we call alpha testing, sometimes we call beta testing, right? So this acceptance testing involves the user, the client. It's usually called alpha testing. So it's for system developed for a single client. The alpha testing process continues until the developer and the client reach the agreement that the delivered system is acceptable. So that's called alpha testing. And the other one is called beta testing, which is very common. Okay, so let me show you some example. Maybe this is a software I used a lot. Not Udemy. Unity. Okay. Here, if if you want to download, this is a game engine, but if you want to download this game engine, sorry, yeah, I have this Unity Hub. So this Unity Hub is a software that helps you to download and manage your versions of the Unity here. So here you can see on my machine I have these different versions of this software, and this one is like 4.2 F2. That's usually that's basically an official version which is released to the public. But also I have this version, see here, 2.0. Here's the beta 9. Okay, a lot of time, a lot of the software companies, they open the beta test version for the public to run. That doesn't mean this is just a testing version. Actually, if you reach the beta testing level, that's already pretty close to the official level, right? But they want to involve more users, more extensive use of the system, and so that they get more feedback, and maybe some potential bug can be found and fixed. And I believe you all have this experience to you download and use some beta version software in your computer, right? Do you have some beta version there? Yeah. But if you are well, a fan of some software and you are keep tracking on those software, sometimes they release the beta version first before the official version, and usually the beta version got more functionalities there than the current official version. So yeah, sometimes if you're really into that software, you use the beta version as well. So that's called beta testing. So beta testing is more open to the client, the actual end user. So when the system is marketed as a software product, testing involves delivering a system to a number of potential customers who agree to use a system and report problems to the developers. Okay, so it exposes the product to real use and detects errors. After feedback, the system is modified and released for more beta or for the official sale. Okay, so we can use a lot of beta testing. There's a lot of beta version of software online, but alpha usually you cannot find it, but it's usually within this internally used, yeah, between the software client and you development team. Yeah. Okay, let's talk about these two test methods. Structure testing and functional testing. So the structure testing looks at, so we also call it white box testing or glass box testing. Okay. So from the name, we can infer that when we are trying to do this kind of white box testing, we actually know all the details to the code level. Okay, if you do not see the code, you cannot do white box testing. So the purpose of the white box testing is we want to check all the logical paths through a module. Sometimes we need a flow chart of a program to help us to create all the test plans, test cases for this white box testing. And we want to check all the passes, and this test can be designed based on the pseudocode it isn't possible to test all possible combinations of passes. Yeah, this is pretty important. Remember this. It's impossible to test all possible combination of all the passes, and also it's impossible to enumerate all the possible input of the test cases. Enumerate all possible test cases is impossible. So that's why we need all those techniques to do this. Okay, here it is impossible to test all possible combination of passes, but we should try to test each pass once. We want to exercise every independent execution pass through each component. All statements should be executed once the conditional are tested for both true or false cases. Okay, so we said it's impossible to test all the possible combination of the passes, right? So, well, it could be maybe thousands of them. Depends on the complexity of the code. But what we can do is we can make sure every lines of code are at least executed once, right? We can ensure that. We just cannot do like let me put it on the blackboard. Let me do it here. Okay, so suppose this is a flow of your code. Okay, at some point it has a branch. Maybe it's a if else it has a branch, right? And then we have a whole bunch of branches. And branches. Maybe it's a whole lot of them. So it can be branches, right? Sometimes if we use a case, switch case, those kind of things, you can have even more branches. Like here, we can have assume this is a case switch. You can have a whole bunch of them here, right? So that actually makes a lot of combinations there. Yes. So what we want to do is we make sure just every branch we go there once. That's it. We don't want to do like let's see. Here we actually, there's a possibility that some branches combine together, right? And there's another branch, something like that. So what we want to make sure is just every branch we touch them, but we do not list every possible branches. But here, okay, for example, for this branch over here, all right, we can do this. We'll go from here to here, from here to here. We touch this branch, right? Another possible way is we go from here all the way to here, go down, and we can also touch this branch over here, right? So we can have this green line, green path to touch this branch, or we can have this red path to touch this branch. What we want to do is we do not need both green path and red path. We can just have a green path or red path. That's enough. Okay, so that's white box testing. White box testing, yeah. So independent pass through a flow graph is a yeah. Yeah, let's take an example so that will be more clear. Hosting. Java application. Okay, let's write the code. Assume we have a code. Float test. Okay, we take an integer, maybe another integer, and a third integer. Four integers and a float. Okay. So if A is 0, we just return 0. Maybe we should write the F. Okay. And 0. If A equals to B or let's assume this code. So what it does is we have a for input. If the first two equals or the second two, if A equals B or C equals to D, okay, then we return the we return 1 to the x, yeah. No, we return where is the return? 1 divided by x, yeah. But if this if we have an input of the A is 0, then we just return that 0. Okay, so right now what we want to do is we want to touch every branch, I mean every single statement here in this function. Okay, so how many test cases do we need to touch every branch in this function, this simple function? Just this testing function. How many test cases there to do the white box testing? I mean, to do the white box testing, we just want every statement to be executed at once, at least once. 13. Yeah, let me yes, once again I want to use this. So right now we have a B, C, and D, right? Here we actually have this one over here. That's the branch if A is 0 or not. We want to analyze that with this flowchart. So this is A0 return 0. Here we start with the branch, right? We start with the judgment. We start here from the judgment. We want to say if A equals to 0, right? So here, if A equals to 0, we return 0. If A is not equals to 0, we go to the next branch, right? not branch, we go to next statement, which is we give the value 0 to x. So here we need also to put this branch conditions here. This is a yes, this is no. Right, any problem here so far? Right, this is the flow so far, right? And then here, after the x equal to 0, we meet another branch, which we use the diamond. So the condition is we go to this branch. A equals B plus A equals Z, yeah. And if that is a yes, we go to this branch, x equal to, we go to this branch, we give value 1 to x. Equal to 1, but so this condition is actually yes, but if it is a no, it is a pretty rough picture. These two, they can go into the same block because there's no branch in between. They need to be executed together. They will be executed together. Turn E, sorry. This is a no condition. Right? Does this finish? Does this flowchart finish describing this code? Anything left? No? Okay. Think about here. After we give the value 1 to x, what happened? Actually, there's another connection from here. Let me show you. From here to here. Do you think so? Right? Yeah. Don't forget all the flows. So that's actually finished everything, right? So what we need to do if we want to cover every single statement. Okay, let's see. Let's use the blue, the red one. First is we start from here and we go here. That's the end, right? The second one is we start from this branch. Okay, go here, 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 all the way down to the end, right? That's it. Sorry. I should use another color. This is another pass, right? Also, we can have a third pass. Go from here to here. Go all the way to the right. And then we go to the end. So there are 3 possible paths on this flow chart. Right? So if we want the optimally to execute these 3 paths, 3 test cases should be enough, right? 3 test cases should be enough. So here, let's first pick this red path. What test case should we select? Yes, a equals 0. We just need to input a with a 0, right? And then if we want this green path, what is the possible value? And yeah, here we need to be careful. Here it says a equal to b or c equal to d. So as long as any of this is meet, it goes to this orange path. So here you want to make sure your test case is a do not equal to b, and c do not equal to d, and a does not equal to 0, right? So our test case here is first is a. Well, our input we can just wait. Okay, and then that's the green path. How about the orange path? What value? Yeah, we just gave a same a and b, or we gave a same c and d. But be careful, we do not want a with the value 0. Alright. So that's how we cover this. So let's write it down. First test case could be a equal to h0, maybe a, b, c, d, e, right? E actually doesn't say anything. So it's a, so it's 0, 1, 3, 6, 0.5 float. That's test case 1. And test case 2, try to make a test case 2. We want to go the green path. Shall we use 0? No. Okay, so give me a test case. 2, 4, 8. Green. Can we do 8? No. Correct. We can just put a 6 here. Right. And maybe 0.6 of this point. So that's the green path. And how about the orange path? Can we do 0, 0? No, because 0 is excluded, so we can do 2, 2. The other thing doesn't matter actually. So that's all the 3 test cases which can cover the 3 passes. But why do we want to cover all the passes? What kind of error are we trying to identify? For example, for this code, you can easily find this. If x is 0, this thing is kind of illegal, right? Because you cannot divide something by 0, right? So this becomes illegal. But if you actually go back to here, if you go to red case, that thing won't be discovered. That's illegal statement won't be discovered. And if you go green pass, it will also go through. But if you go the orange pass, that's when you find actually that problem. Because sorry. If you go orange, this is fine, because E is going to equal to 1. But if you go to this green pass, when X is 0, this becomes illegal, right? So that's sort of kind of the idea of the white box texting. You want to cover every branch at least once. Yeah, sometimes maybe you have to cover something twice, like this X equal to 0. X equal to 0, not A equal, sorry. We assign 0 to X. So this block here is actually on both green path and orange path. So that means it's, well, we want to execute every statement, every branch at least once, but not exactly once. Okay. Yeah. All right. So that's white box testing. And next is the functional testing, which is verify that externally observed properties of the software unit conform to our specification, and determine the functions, whether the overall purpose has been satisfied. This thing we can easily think of this if we want to test the calculator. We give 2 plus 4, it returns to 6. That's a very typical functional test case, right? We try to see if that actually works. And also we call it the black box testing. We don't know about, when we do the black box testing, we assume we do not know the code. We do not know the internal path of the code. And the set of input data supplied and outputs are verified against the expected results. So we have, when we make the test cases, we have a test data matched with the outputs, expected output. And the testing focuses on the interface between the unit and some external entity, such as a test driver. Okay, so when we have let me ask you this question. When we have the white box, do we still need the black box? Can white box fix everything? Find everything, every error?
I cannot find every error. It depends on what error we are looking for. We can use black box testing to find some errors, but white box testing.
Yeah. So recall, when we talk about white box, what we do is basically we just cover every branches there, but we don't know if that function is met or not at all, right? We can just have a whole bunch of branches, a code there, doesn't make any sense, and it cannot, like if I put 2 plus 4, input this 2 plus 4, and it return 1,000,000. Okay, we know that's wrong, but we do not catch this kind of error from the white box testing, right? Because in the white box testing, we see the code, we execute them, okay, it goes through, everything works pretty fine. That's not enough, right? But this black box testing is functional testing. Is, well, you have this logic of expectation of how the system is working, and you generate the test cases, use this kind of the logic of the system, so that you can have here against the expected results. When you have an expected result, that really means you know the logic of the system. You know what kind of behavior is correct from the system, right? If the system is functional correctly, right? Okay, let's talk more maybe in the next class. All right, that's it for today. Thank you very much.